So I'll figure it out and have it for next week.
It's a pain. I don't like even doing this, to be honest.
Yeah.
It's not even like he looks at it. Like, none of our other videos have had any views, so.
Yep. Go figure, huh?
I figured out why I was getting my answer, and I am convinced it is correct.
Okay.
In order to complete the square, you have to add 9 to both 6 and both x and z, right?
Oh, you're right. Because I was doing 3, which is...
Actually, it's a -9, but...
Well, right, yeah, so... Okay, I don't know why I did 3. I just simplified it. But it's got to be x squared minus 6x minus 9. You're right.
And so we get the square root of 18 on the other side, which breaks down to 3 square root 2.
There you go. Okay. Gosh, I knew I did something weird.
I was trying to figure out what I did. I'm just tired. I didn't get a lot of sleep last night.
All
right.
Gotcha. Let me write that down real quick. Because I think you're right now that you said that, because I'd already put 3 in. You know, you can't factor that down more. So yeah, you're right. Exactly. Okay. Second question. That's fun.
This one. Actually,
I haven't had physics in a long time, so I don't remember.
Actually did this exact question last night.
Oh, did you?
Yeah, let's see if I can remember it.
I just know it's a little different for force 1 to force 2 because it's in a different quadrant. So I think, because from here, let's see, that's going to be the cosine, that's going to be the sine.
Buddy, I'm not going to read to you right now. I'll read to you after I'm done with my math homework, okay?
So that's the sine, and that's cosine. Okay. And the magnitude and components. Okay. Okay. 4. Let's see, the inside angles of triangles equals 180, right?
I think so.
Okay. Just trying to make sure I get my angles right. So did you break this into parameters, or did you just do the tangent?
I'm trying to remember.
Because the hypotenuse, not hypotenuse, yeah, the long section should be something. I don't know. Well, I know if I break it into components, that might be easier for me.
I remember I had to find force 2 before I could find force 1.
Yeah, I know it's the force times sine or cosine or something, but it's a physics problem, but I haven't had physics in a long time, so I kind of can't remember.
And I also remember that force.
Is this homework or is this quiz on stuff this week? Because I don't remember that in things I've read.
Yeah. I did this last night. It's the second assignment. It's due.
Gotcha. Well, let me open up so I have something to look at, because I was looking at all the ones I was, for some reason, thinking it was from last week stuff. I don't know why I thought that. Okay, give me 1 sec. Oh, shoot. Okay. Okay, so it is kind of what I was thinking is we need to break it into the x and y. Yeah. Then you take the square root of x squared, or f1x squared plus f1y squared. And that will give you the magnitude of the f. I think that's what I'm seeing just glancing at this, which is kind of what I was thinking to begin with from last week, but I know with physics they have a quick way of doing it. I just can't remember. Okay, so first one's all about graphing. Okay. All right, sorry, give me 1 sec. So it's going to be
Let's see.
I'm almost to where I can square. I think I got it figured out. I just want to make sure I have done it right, and then I'll tell you. Okay, so what I have just for F1 broken into components, I've got basically F1x, which is going to be 600 times the angle sine of 65. And I just looked at how the triangle's made, because this one in the other quadrant, remember, it's a little different. It's flipped, so I think the sine and the cosine are flipped on the x and y coordinates. So that's going to be my x coordinate for F1 and F1x, and then F1y, I'm going to have 600 times the cosine of 25. Is that kind of what you got for general there, or is that not even close?
I think that the equation that that I remember was mg, which in this case is the newtons, so 600
Yeah, that's going to be your force, right?
over cosine.
That's going to be the only number, and the angle
times tan of the first angel plus tan of the second angle. That's the equation that I think I remember.
So yeah, the way I was going to do it probably is going to take longer. I might have it in the homework. Sometimes the homework, actually, I think the homework explains it better than these notes do.
My biggest problem with the homework so far is that I can't access the textbook because they don't support it.
Yeah. Let's see. What do I do for the textbook? So I can't remember. I haven't used it in a while because I just read his notes and then I just go straight to the homework. Let me see if I can get in there. Oh yeah, I don't exactly. Yeah, same here. I don't have a way to look at it. I thought I did. It's my other class though. One way, I think your way would work as well. All I would do is just mix those together to get F, and then F2, which would be kind of what you have, and then to get F, it's the tangent, whatever. Because that's what you actually want to find out, is that which is going to be sine over cosine. So let's try that real quick. So tangent. So for F1, you have 600 tangent and 90.
Wait, what?
Well, what do you have for, you said you had tangent. What's the angle you had for the tangent?
Tangent of 25 plus tangent of 45.
Oh, I see. You could do it that way. So what I did is I broke them into two triangles. So you just used one triangle and made it easier that way. I got it. Okay, so that makes more sense. So tangent of 25 squared plus the tangent, or 600 times the tangent of 45. And that should equal
I'm not squaring.
Whatever F. Well, yeah, they're all squared, right?
I'm not squaring anything.
Oh, you're not?
No. Hey, Malachi, what are you doing? You better keep
Yeah, so
around.
that's all it shows in the notes that he's provided.
Wait, he's provided notes? Where?
So you go to the reading assignment. You go to like lesson 10. You click on that, and then it says reading. I click on that, and then it has notes. On the page. But yeah, that's all I see are squared.
Malachi, I told you I will cuddle you as soon as I'm done with math, okay? And then you can take a nap. No?
Okay, let's see. 3D vectors. Give me 1 second. And cross product. We don't want to do that. Yeah, it doesn't really talk about this example in his notes.
I'm just trying to do what I remember doing from last night.
Yeah. So you just added the tangents together, and that's how you got your force?
The cosine of the first angle times the tangents times the addition of both the tangents, yeah.
I guess I don't see where that cosine would come in.
I don't remember.
Because the tangent basically is already going to count for the sine and cosine in each of them. So that's going to be your x and y position. I think. I don't know. Let's skip that question and go on to the next one, then we can hit that one at the end. Unless they're all going to be that hard. And let me take a quick look.
Probably going to be harder.
Yeah, because I have no idea. Like I said, he doesn't even have an example of anything close to it, so I don't. Oh, now it wants us to do cross product.
Cross product is not actually that bad.
Yeah, I just don't remember it. I haven't read it.
I do. Like I said, I did
and then
last night. Wait, we're doing cross products or dot products?
It's 2.
I have not
Down for
done
now.
cross products yet.
Okay, and then let's see what the fourth one is. Uh-oh. There we go. Wants us to find the volume of a parallelepiped box. Okay. Which, as far as I know, that's just actually I don't know. I don't know how to do that one. So it looks like we can stick with 2, I guess.
Yeah, so
I don't know.
I think we're gonna want to do this on Thursday or Wednesday whenever we finish all the homework assignments for the week.
Yeah, because I'm not very helpful because I thought I would know at least some of the stuff, but I'm not remembering. Well, here's what it shows. I don't know. I have no idea. I know it's confusing. I'll tell you that. Yeah, do you want to just plan for Thursday? That way, I'm not wasting your time because I don't know what I'm doing.
Well, I think
With
that
vectors.
I think that we have to submit this quiz if we exit out. So.
Oh, do we? So
yeah.
we'll know for the next week. Okay. Yeah, because they're all significantly harder than the first question. Here, I've got an idea. Let me pull up the homework. Real quick. Does his shortcut? Oh, I guess you might not use them. Do you just go straight to my math lab?
Yeah, because the shortcuts don't work.
Okay, yeah, that's what I was gonna ask because I've tried them and I don't know if it was just my computer or what. So
there's a handful of things about this course that I'm not happy with.
Mm-hmm.
I don't think that generally it's his doing. Actually, I think he's a really good teacher, but I just think that the course itself needs to be redesigned to fit better. Like, I hate having to work in my math lab through iLearn.
Yeah, exactly.
So frustrating.
Okay, we were looking at vectors, it looks like. And you can't right-click to open it in a new tab either. All right. So let me find a question that's like it, and then we can work through it.
I have the question that's like it.
Okay.
And I know the problem is that they don't have anything.
Well, on the first one about vectors, they have something about velocity of airplanes. But now my computer's frozen, so
it's question 8 in vectors.
Can't look anymore.
I don't think we're supposed to be looking at this, but oh well. Okay.
Huh, yeah, it's frozen now. I can't look at anything.
That's not surprising with my math lab, to be honest.
Yep. Okay, reloaded. So I don't think it's in the first lesson. I wonder if it's under vector applications. I bet that's it. This one only has 7 questions. Jeez. Yeah, it seems weird to have a group quiz on stuff we haven't studied yet. It should be the stuff we'd already studied last week. An equation through
I think the idea is that we do all of our homework and then we move through.
Yeah, I'm having a hard time going through any of them. But I'm pretty sure once you find force 1 and 2, you can just add them together to get your actual force that we're looking at, I think. Find distance from. Well, it's not in that one. Yeah, it's too bad it doesn't have an example of something like this.
Well, there's the exact example is in number 11, vectors, problem 8.
Oh, okay.
But
I tried to go into that, but it froze, I guess.
Walkthrough, it's really annoying. But I got it right, so I'm kind of basing my answer off of that.
Oh, yeah, here we go. Textbook, or there's a video.
The videos almost never help me.
Yeah.
Because they almost always go off on a different problem, it feels like. I'm sorry, bud. You shouldn't have headbutted the window.
Huh. Well, I tried to open the video, but it's not opening anything. There's nothing there. Oh, here we go.
There isn't either.
Okay, so it has it broken in kind of how I was going to do it. It was the cosine and sine, but they did it differently. A little bit. Is there a way I can share my screen on here? Oh, here we go. Shoot, where is that? Right here. Oh, there we go. Never mind. Okay, so sharing now, right? You can see my screen.
Yep.
So that's what I was just looking at in the video. Here, I'll make it bigger. As soon as it will do it. What? I wanted to get maximized. Bless you.
Thank you.
Okay, let me go down. Well, the only thing I can think of is watching it and seeing where it goes if you don't care. But yeah, see how they broke it into triangles? I did that, but I did it up this way. Inside it. So he got a minus cosine for his x, and that still stayed as sine. So that's probably the right way to do it. Do you want to watch it real quick and just a little bit anyway? See how they get it set up? See if it's similar to how you did it?
If you want, yeah. But you gotta stop bumping your head.
What's that?
Sorry, my son just keeps coming up to me and telling me he hit his head.
Oh, gotcha.
Oh, so it looks like I was just slightly off.
Sorry, what's that?
Looks like I was
That's
just
how.
slightly off.
Well, you're pretty close. It's pretty math intensive there. Well, we only have a little bit left, a minute left, or do you think we got it figured out?
Well, we can at least do the first part.
Okay, let's see if that's that gets us. Okay, I'll get out of screen share real quick if I figure out how to do that. Oh, come on.
And then I got problem 3 done.
Oh, you got problem 3 in the time I was watching the video?
Yeah.
Perfect. Okay, let's look at number 3. Oops, that was the homework. Okay, so given the vectors, so the cross product, what's the formula for the cross product?
Oh, you want to do number 3 first? Okay.
Oh, I thought you said that's what you were doing.
Oh, no, just
No, we can do 2.
I was done with 3 so that I can walk you through it as soon as we're done with 2.
Oh, I got, okay. Sorry, I misunderstood. Okay, so boy, that's crazy. That's a weird way to figure things out. I know there's an easier way to do that than what he just did.
It ended up being 600 over sine of.
Yeah, it should.
It'd be sine of 40
Yeah,
in our case plus tan of 25, 45.
yeah. Let me. The tangent should be 45. And it looks like the cosine and sine are the other angle. So that's going to be 25. And that's what you said, right?
Yeah.
Okay.
Okay. Hey, I got it right. Apparently, that's the exact same thing as the equation that I did.
Well, there's definitely more than one way to do things, so
Yeah, I was going to say,
understand that.
Apparently, you're right. There is more than one way to do this problem.
Okay, that's one.
Not quite sure how our equations equal, but apparently they do. So that means that the F1 is 451.5.
$451.5. Let me see what I get. I've got a dumb calculator, so I've got to Yeah, that's about what I get too. So I was 0.6, but I was also rounding.
No,
So I just want to see if I get somewhere close. Yeah, that's if I had to do that from hand, that's going to take a little time.
I wouldn't be able to do that from hand.
Okay, so that's what F1's going to be, right?
F2 in the homework ended up just being 600. I don't see any reason why.
Oh, sorry, you're breaking out. I didn't hear anything you just said.
Oh, sorry.
No, you're fine. It's probably my connection.
F2 in the homework ended up being 600. Or in other words, the pure Newton force.
Well, the way I think I could figure it out is you subtract the 600 from the 451.
No,
And wouldn't that give you your F2?
No.
Because you can add and subtract vectors.
I am confident that's not how you get F2. Like I said,
It's probably not, but
in
it should be something close to that.
In the homework, F2 is just 600.
It's just 600?
Yeah. Because like I said, I had an almost identical problem, except for instead of 45, my angle was 40.
Huh. Well, the only reason why that would be 600 is if F2 is straight over the 600, because the sine of that would be 1. So that would be 600. So that seems weird to me that it would be more.
I could not honestly tell you.
I don't know either. I was just saying if I subtracted it, I know that it doesn't work that way, but
I mean, do you want to continue on with the video and see what he did?
that's the end of the video.
Wait, it doesn't show you how to get F2?
Where did I go with the video? Oh, I clicked out of it. But yeah, that was the end of it. He just finished there. Let me try textbook and see what that does. Maybe it'll let me in this way. I can't remember. Oh no, I have a minute left. Okay, yeah. Sorry, I thought I clicked out of it.
Oh, awesome.
But let me see if it opens with the book, because that'll be faster if I can have an example. It's thinking. I wish we could download our textbook. Then it would be so much easier.
Yeah, no kidding.
Okay, I've got the textbook open now, I guess. So I just need to find the right page. And I'm just gonna screen share and we'll finish that video, and then if that doesn't answer it, we'll go from there.
Oh, I know the answer. Sorry, I know what I did.
Okay.
It just happened to equal 600. I'm not sure that it will this time, actually. Oh, dang it. There we go. Okay. So we got 451.5. What I did is I multiplied it by cosine of the first one divided by sine of the second one. Which equals 578.7.
578. Yeah, I'm gonna work through one real quick and see if I can get an answer real quick. Because I think it's what you're saying, but I just want to make sure.
I see how it is. Don't trust me. What?
No, it's not that. It's that I don't understand what the thing is, so it's kind of confusing.
It is completely confusing. I have no idea how I would do this on a test.
Yeah, it would be crazy.
Malachi.
Okay. I get 494.3 if you round it.
That is not what I got.
But I did F2 through the what do you call it? Like the distance formula.
Yeah.
Basically, because I have the weight going up and the weight going to the side. Square both of those, add them together, and take the square root. That's how I did it. And what was your answer? 500 something?
578.7.
587?
578.7.
Oh, huh. Well, your answer was right last time. Like I said, I haven't really gone through it, so we'll just go with your answer and then go from there. So we're not spending all day.
Yeah.
Oops. So that's going to be 578.
Okay.
Okay, so find F1. Or is that what we already did?
Now what we have to do is we have to plug it into the equation where it's negative cosine and plus sine. So it's simply negative cosine 25 times the first answer. And then the second.
Oh, I see.
Yeah, and then the second part is sine 25 times the first answer.
Gotcha. So you can get your okay. So let me see what I get for that and make sure it's right.
Okay.
So for the first one, I get negative 409.2.
Yep, that's what I got.
Okay. And for the second one, I get 190 for the second one.
190.8.
Yep, exactly.
And then F2 is both 409.2 because it's a 45-degree angle. Okay. Thankfully,
So that's 409.
Thankfully,
yeah, because it doesn't matter which way you do it, it's going to be the same because of the angle.
Yep.
So times. So you said it was 400 what again? 90?
It's the same thing as the first one. The very first part. So 409.2.
Oh, yeah. Okay. And that's for F2. Oh, I just erased my answer. Of course.
Yeah, It's for both of them, 409.2.
For F2?
Yeah.
Okay, well, that's all for number 2. That took long enough, huh? Okay, now number 3.
The next one's going to go pretty fast because I understand it pretty well. So for the first part, we need to find I times I, J times plus J times J plus K times K. So if you do
and
that,
that's
it ends up being 80 plus 44 plus 0, which is 124.
do we need to take the square root of that at all?
Nope.
Or you just because we were getting rid of it. Gotcha. Because it's already based. Okay. So 124.
Well, to find this first part, there is no square roots involved at all.
Okay.
However, this next part does involve roots and square roots.
So we have to square root them to get just basically a distance formula or to get V. Pythagorean's theorem, essentially. Because for V, it's all the V, I's, J's, and K's squared and added together, then square rooted. Or is there a different way to do it?
I'm not sure what you're talking about right now.
Oh, well, to get the next answer to V.
Oh, gotcha. Okay, the length of V. Okay. To get the length of V, you just, it's the square root of the I squared, J squared, and K squared.
Okay, yeah, that's what I was wondering. So.
Yeah, the square root of 100 plus 121 plus 4, which equals 225, which equals...
Which is 15.
Or 15?
Is it 15? That's just wondering. I'll look it up.
Square root of
it's
55 is 15. Yep.
Okay.
Guys, no.
All right, let me plug and chug you and see if it's the same answer you got.
I think my arm was broken.
I'm sorry.
So I get 4 square roots of 5.
Yeah. I left it at square root 80, but yours is correct.
Okay.
Hey, Malachi, give it back to your sister. That was rude.
Okay.
And then
now it wants to find the cosine.
It's just basically adding together everything you've done so far. So the top part is the first answer, so 124.
Mm-hmm.
Then the bottom part are the second two multiplied together. So it becomes 60 square root 5, which we can then simplify. We divide it by 4.
Is that 124 plus that product, U and V?
1 second.
Yeah, no problem.
So it's... Hey, guys, stop fighting. So it becomes the dot product of U and V over the length of V times the length of U.
Okay, so it's the dot product over the length of V times the length of U?
Yes.
Okay, I see. I wasn't sure the formula on that.
Guys, no, stop.
So you can divide. So it's going to be 31 over 15 square root of 5.
So I got 31 over 15 times the square root of 5.
Okay, yeah, that's what I was just asking. Yep, perfect.
Malachi, you are fine. You don't always get your way. That's life. Deal with it. Yeah.
So how do you get the cosine of theta then? Or is that it?
How do you get the cosine of theta? That is the cosine of theta.
Yeah, that's what it wants next.
That is the cosine of theta.
Oh, that is how you find it?
Yeah. That's the answer.
Oh, well, that's nice.
Noel, you want me to turn off your TV show?
No.
Then go watch it.
No, it's broken. See? I can't find it.
Oh, I'm sorry. I can't fix that.
Okay. I think it's
Okay, so the next one's a scalar component.
So the next one's the dot product over the length of V.
Oh, to find that. Okay. Over the length of V. So it's going to be 124 over 15.
Yeah. Yeah, there's no way to simplify that, so that's just what it is.
Right?
Now the next one is annoying. I did not like this.
Find the vector projection of U onto V.
No, it's the dot product over the length of V squared times V.
Yeah, that's it, huh? So
I still need to finish factoring it out, but it's 124 over 225 times 10i plus 11j minus 2k. Gross is what it is.
oh, it's the actual V. I see. Because I was putting the length of V for some reason.
Ugh.
So yeah. So you just have 124, 25, and then just multiply it by the parameters. Should be 10, 11, and minus 2.
Yep.
That's how I'm going to leave it. Oh, type your answer in terms of IJK.
Do not factor. So maybe this is actually okay leaving it like this. If not, we might be able to get them to go back and look at it at least.
Yeah.
That's fine with me because I really don't want to do that.
I don't blame you.
Alrighty, last one. This is something I have not done.
Almost ready. Minus 2J. Okay. Good enough. I think that's all done. Okay, so number 4 now. Find the volume of the parallel pipe box. Okay. I just Googled it so I could kind of see because the textbook's not very easy to get into.
If you can even get into it.
Yep. So let's see. So they have the volume equals, I don't know what the symbol means, but the straight pipes. I say absolute value, so I'm just going to say like it probably means something else, probably for the vectors, but it's A times the dot product of B, of the cross product of B of it. Here, let me just screen share that way you can see what I'm looking at. Because one, I don't know what it's called. That makes it hard to say what it is. So that's what I'm looking at. Is I think it's this one. Is this formula right here? I think is what we're gonna do. So the volume is gonna be A dot product B cross product C or whatever. So I don't know. That's how I'm gonna try doing it. What's our homework look like? Let me write these down, then I'll go back to that page. So 3i plus 2j, that's going to be u. B is 2i minus 3j. W is 4i plus 3k. Okay. So I'm going to call UA, VB, and WC. Sounds good enough to me. It's going to be 320 times the cross product of 2 minus 3, 4. Oops. 403. Okay, so if it's I, yeah, sorry, if I'd realized it was already on the homework we done, I would have gone over it, but now I'm trying to figure out dot and cross product on the fly.
Yeah.
Which that's not very helpful. This looks more like linear algebra than calculus.
Very much so.
Yeah. So remind me how the cross product works. That would be, I'm looking right here at this line here. So I'm looking at the I. Is that going to be 3 times 6 minus 5 times minus 8?
I am not entirely sure. No, like,
Well, the answer on here says it's 22, and that's how the only way I can see how to get it is 18 minus 40 would be 22. So that's got to be it.
yeah.
Shoot. I even put in the wrong numbers. That's funny. Because I was looking at how they did it. Okay, now it makes sense. I think I know how to at least get to the third line.
Yeah.
-3403. Is it always minus?
Yeah, it has to be. Otherwise, it won't work.
Okay.
Actually, it still doesn't work in the last one.
It didn't?
No.
Hmm.
I don't understand why they got negative 34.
Okay, it's 2 times negative 5. That's 10. And it's going to be minus 8 times 3, 24.
I see it. I see it now.
Yeah. I don't know. I'm hoping that's right. I mean, that it looks right just at a quick glance. But like I said, I'm trying to figure it out as we go. So
No, you're right.
negative 9 minus 0. 6 minus 16. So it's going to be 0 minus 12.
Yeah.
Okay, so for your parameters, you get negative 9, 10, and 12.
Sounds right.
Okay. So now it's the cross product of 3, 2, 0, and negative 9, 10, 12. But I don't know how to do the cross. What you showed me. Give me a sec.
Yeah, the dot product is just multiplying.
It's easy. So it's 3 times negative 9, right?
Plus, yeah.
2 times 10 plus 0 times 12.
Yep.
Okay. I couldn't remember because I was gone through all my papers. So negative 27 plus 20, so I get negative 7.
Wait, is that even possible? No, because it's the absolute value.
Oh, it's absolute value.
So
So yeah, I didn't realize that's what that was. So it's going to be 7.
Okay.
Is that what you get?
Yeah.
Okay, so it's an absolute value of that. See, then that's for the cross or the dot product only, right?
Well, it's because it's a volume. A volume can't be negative.
Yeah, that's true. If your volume starts going negative, you're probably going to die, right?
I would assume. All right. Well, no matter what, I'm ready to submit this.
Okay, here, I'll submit mine first, and then we'll see how we did. It says we missed question 3. We got half of it.
Oh, I bet you anything it's that last problem.
Yeah, it's well, no, it's problem number 3. It's the length of u, or yeah, the length of u is wrong. It says, and then the cosine of the angle's wrong.
The length of u is wrong.
But here's what I put. Maybe I wrote the wrong answer. For the length of u, I put 9, and for the cosine of theta, I put 124 over 35. 135.
Whoa, yeah, you put that wrong. The length of u is 4 square root 5.
I wonder why I put 9.
I have no idea. We're not talking about that because I put
Let's see where I put that.
I put square root 80, and then you said 4 square root 5, and I was like, oh, yeah, that's right, because 5 times 16 is 80.
Yeah, that's what I have. I don't know why I put 9. I think it changed my answer and I didn't realize it. And then the cosine of theta, that was
Should have been 31 over
41. Yeah, okay. So that's why I got it wrong.
Did you get the last
yeah.
that wrong?
Yeah, it says I got the last one wrong too. But I probably wrote it wrong as well.
Okay, well, I'll submit this as is then, because everything else is right. So
yeah, I put a different answer than what I put, but it said 248 over 45i plus 1364 over 225j. I don't know where that even came from.
Yeah, it changed mine. No, it said the correct answer is 9. That's what it's saying.
Oh, I thought I put 9.
Is it 81 instead of 80? Because 8 squared is 64 plus 4 squared is 16.
I
No,
don't think that's right.
that's not
There's
right.
no way that's
It is
yeah.
square root of 80. It is not 9. He screwed that up.
No. Yeah. So it did want us to multiply all the way through, even though it said
Yeah.
do not factor. Oh, I guess we left it in factored form.
Oh, that's true. Oh, well.
I didn't think of it that way.
But I mean, we could probably still get 0.25 of this question, right? If we sent him an email.
Yeah. That's dumb. See, that's the problem with some of the computers things.
Yeah, because
But yeah, that's funny that it's saying the wrong answer.
Okay. All right.
Well, how are we doing for time? About noon, huh? Wow, that's a long one.
Yeah. Well, I guess we'll go ahead and meet next Thursday instead. That way,
Yeah, same time.
Yeah, that way we can actually get our homework done ahead of time. Hopefully.
And then this will be way faster. And you don't have to waste as much time. Okay, so Thursdays for now at 10.
Yeah.
Okay, perfect.
All right.
Well, thanks for your help. I'm going to have to go through all the homework because that's a lot of different material that I don't know.
Yeah, no kidding. This test is going to be so much fun.
I can already tell.
All righty. Well, I will talk to you next week then.
Okay, sounds good. Thanks.
Yep. Bye.
See you. Bye.